All right, now we have a problem on Newton's law of cooling. So this problem says, Susan has a kiln and she fires ceramic greenware at 675 degrees. After turning off her kiln, she must wait until it reaches 150 degrees to open the kiln, where room temperature is 70 degrees. The gauge on the kiln reaches 500 degrees in 15 minutes. That's after she turns it off. How long must she wait to open the kiln? Or how long before it's down to 150 degrees? So, first of all, we know that the temperature of the air temperature on the outside is 70 degrees. They told us that. So, big T stands for the temperature or room temperature, okay? U sub 0 is the amount of the temperature we start with, and we're going to say that the temperature we reach of the oven or the kiln reached 675. So that was what we started with, okay? And then they always give you a little caveat. So it says, the gauge on the kiln reaches 500 degrees in 15 minutes, okay? So I'm going to use 500 degrees in 15 minutes, and that's how I'm going to solve for K. So this is temperature after time. So the temperature after time was 500 degrees, because it was after 15 minutes, right? And we said big T was 70, plus U sub 0, which is 675, minus 70, and that would be E to the KT power, and we said time was 15, so this will be 15T. Okay. Oh, sorry, 15K. We already knew what T was. K is what we're solving for. All right. So this, to simplify this a little more, we get 500 is equal to 70 plus 675 minus 70 is 605 times e to the 15k. All right, so the first thing I do is I subtract 70 from both sides. So 500 minus 70 is 430. And I have 605 e to the 15k. All right, last little step here is I divide both sides by 605. So now I have 430 divided by 605 is equal to e to the 15k. Remember, when the variable that you're trying to solve for is in the exponent's place, to solve it you take the log of both sides. So I'm going to say natural log, okay? So the natural log of 430 over 605, and I know that would reduce, but I don't really care. I'm going to put it in my calculator anyway. And the 15k is going to go in the front, so I go 15k. Natural log of e is just 1, so that cancels. Then I'm going to divide both sides by 15. So I'm going to go ahead and turn my calculator on, and it says natural log of 430 divided by 605, and then divided by 15. So I get negative 0.0228. K is equal to negative 0.0228. That is the cooling rate of our kiln, okay? The cooling rate of our kiln. So now, the next part is I need to answer the question, how long must she wait to open the kiln, or how long before it's going to be 150 degrees? Because she can't open it till it's 150 degrees. So I'm going to kind of use this formula without the 15k, because it's not 15 minutes. I'll be trying to solve that, but in this case I know the k. So I'm going to say 150 is equal to 70 plus 605 e to the kt power, but now I know what k is, right? K is negative 0.0228 t. Now I'm trying to solve for time here because it says how long must you wait, so t is what I'm trying to solve for. So to do this, I subtract 70 first. So I get 80 is equal to 605 e to the negative 0.0228 t power. Then I divide both sides by 605. So now I have 80 over 605 is equal to e to the negative 0.0228t. I take the natural log of both sides. And so this would be negative 0.0228t. Natural log of e cancels. And so I'm just going to divide this by negative 0.0228. And that'll give me t is equal to this. So I just have to type that in the calculator. So it'll be natural log of 80 divided by 605. And I'm just going to go ahead and enter, divided by negative 0.0228. And so I get the time is 88.74. That would be minutes. That kind of makes sense. It's like an hour and 28.74 minutes. So that would be my answer to my question. How long must she wait to open the kiln? She needs to wait 88.74 minutes. Ta-da! That's Newton's law of cooling right there. Newton, the father of calculus.